We see its familiar, iconic delta shape all around us. Even in silhouette, we instantly know what it is. The Space Shuttle. Versatile, reusable, revolutionary. The first and only spacecraft of its kind. For 30 years, the shuttle is known for stunning achievements, heartbreaking tragedies, and ultimately triumph in the human will to explore, work, and live in space. Like no other spacecraft before it, the shuttle is able to launch our nation's dreams of exploration. For 30 years, the shuttle has risen into the sky. As spectacular and familiar as a sunrise, its achievements can be taken for granted. With every liftoff of the dreams of exploration, and for the people who work on the shuttle, the pride of accomplishment. What does it take to get a shuttle to fly? For 3 decades, shuttle launches involved the entire nation, with parts coming from more than 37 states around the country. Not a product of NASA, but a product of America, with human hands putting loving care into each and every component.
Well, getting a shuttle ready to fly is a tremendous effort by thousands and thousands and thousands of people. The external tank arrives by barge at the turn basin. So that comes on a barge from Louisiana. And the solid rocket booster segments come to us on rail from Utah. And so they all come together. We stack the boosters, then we attach the external tank, and then the orbiter gets attached to the tank, and we roll out.
A shuttle launch, it's the icing on the cake for all the work that they've done. The launch team includes folks that worked on the hardware or the software months before in a building that in the middle of the night that may not have any windows in it. They know that you don't have to have a highly visible job to be important in this business.
So on behalf of the KC processing and launch teams, wish you good luck, Godspeed, and we'll see you back here just after Thanksgiving. Well, the launch here is very, very special. I haven't seen one from outside for over 10 years. I'm always in the control room. But thousands and thousands of people come to Titusville and Cocoa Beach and Cape Canaveral to see a launch. You watch the tourists, come here special. The kids, just in awe when the orbiter lifts off. It's a tremendous feeling of accomplishment. And to think that we're doing it on behalf of the country and now with the International Space Station on behalf of all the international partners, it's a tremendous feeling.
Only ice you'll ever get in Florida.
Shuttle launch is quite an experience. You need to wake up, put on your fancy clothes. You have a breakfast together before you put the fancy clothes on because you don't want to get them dirty. So you have your breakfast and you put your fancy clothes on and everything, put on your space suit, and you walk out into the Astro van. They drive you out there and you get in the launch pad.
Leading up to the launch, it's a lot of training, and it's something you've been preparing for really kind of all of your life if you think about it, because this whole aspiration of being able to go into space is something that starts pretty early on for most people. Even though you're exhaustively trained for it, nothing really prepares you for what you're actually going to feel, because there's no way to really simulate that. So it really is, on-the-job training, as the as the saying goes.
The launch is a pretty incredible experience, and I've heard a lot of people attempt to describe what it feels like. I've heard people say, oh, it's like getting hit in the back of your chair with the baseball bat. It's nothing like that. It's very hard to describe, in fact, because you're going from not moving at all to 26 times the speed of sound in only 8 minutes. And so the tremendous sense of acceleration is not one that you can really prepare for unless you've done it before.
And then at 6 seconds, the main engine's light, and you feel that, and the shuttle pitches and then kind of comes back upright at 0 in the countdown. And then the solids light. And then there's no doubt you're moving.
And I remember looking over and seeing on the display, yep, all those main engines are 100%. And then it was like, boom. And we were kicked off the pad.
And within a couple seconds, the thought went through my mind was, man, we're like far away from home. Already, you knew you were going someplace far away.
And as we go, then we separate from the solid rocket booster, and then the ride becomes very smooth. There's no shaking much anymore, but we are outside the atmosphere of the Earth, and we can accelerate real fast now. We have to reach 25 times the speed of sound. So as we accelerate, we start feeling the G acceleration and being pushed back on our seats. In the next 5 minutes, we're under 3G, which means 3 times our weight.
And that seemed a little bit more than 3Gs I've pulled in other situations. And I think, again, it's just because of the excitement of this being a real flight. And I felt like I was fighting much harder to get breath. And it's over about a minute and a half time frame, and then all of a sudden it's off of you. And you're like, wow, things are floating up, and we're really here, you know, this is really where we wanted to be.
Dottie, how do you like space?
I love space. I still feel like I'm
better and better.
I feel like I'm hanging upside down, but I guess I'm not.
There was this quarter of a second transition into real heavy to, whoops, floating. And that's when you have to adapt to weightlessness. It's a great ride. It's a great ride.
Before the space shuttle, spacecraft like this Apollo capsule are built for no more than 3 astronauts. Landing in the ocean and recovered by aircraft carriers, the space capsule and the 360-foot rocket that launched it are never used again. When the shuttle rolls out of the factory in the 1970s, it is obvious that America has taken a huge leap in spacecraft design. The largest, fastest winged hypersonic craft in history, the shuttle lands on a runway and can be refitted to fly again and again. It can hold up to 7 astronauts, and its payload bay can haul cargo to and from space. Space flight and how we conduct it changes radically with the shuttle concept.
But you can imagine the early spacecraft, barely the size of a desk for 1 or 2 astronauts. Now the spacecraft is the size of an airliner, and it has thousands of components and miles of wiring, and we were making the transition from the era of wires and switches and meters to digital and computers.
The shuttle's flexible design means it can carry out a variety of missions not possible before, including scientific and astronomical missions. NASA needs a new breed of astronauts, not just flyers, but scientists, engineers, doctors, and other disciplines. A whole new world of opportunity opens up for astronaut candidates who may not have applied to NASA before the shuttle. In addition, a space program actively recruits women and minority astronauts for the first time. One of the earliest uses of the shuttle is for space lab missions. For the first time, an entire laboratory, the size of a school bus, can be hauled into space in the shuttle payload bay and returned to Earth. Built by the European Space Agency, Space Lab is a prime example of early international cooperation in space. The shuttle missions allow scientists and researchers from around the globe to participate in the high-flying experiments. But why conduct science in space?
By going into space, it allows us to be able to study everything that we can think of without the presence of gravity. And if you think about it, everything that we've done in the laboratories here on Earth, all the science that we have had the presence of gravity. And so this is a very, very unique opportunity that we have so we can find out just how gravity affects all different kinds of systems.
Shuttle science missions also study the Earth itself, aiming instruments located in the shuttle payload bay to monitor the Earth's ozone layer. The shuttle also launches satellites to further observe the Earth's atmosphere. Over time, the data gives researchers important information about our changing planet. The shuttle also orbits the Earth with a series of radar mapping missions, allowing us to view the features of our world with a new level of detail. Shuttle missions also allow students to participate in science. Two programs, KidSat and EarthCam, allow students to make Earth observations using a remote-controlled camera on the shuttle. For the first time, students take an active role in a space mission.
My name is Ebony Miranda. We want to know if you can start the car on top of the track.
Okay, let's try the top.
Astronauts also take advantage of space to partake in educational events with students from around the world. In the microgravity of space, experiments are filmed and distributed to schools for further learning opportunities. The shuttle is not only a science vessel. Commercial clients from around the world take advantage